YouTube. Wow, it's working. Nice.
Yep.
Audio's here. Well, hopefully it's going to be more people coming in. If there's people that want to see the talk that is outside, then you should get in. Otherwise, you'll miss out. All right. Are you excited? Yeah. Cool. So it's been an amazing week so far. So we got about 265 slides to go through in the next 45 minutes. So you better buckle up for this one. I'm STÖK. This is JOOHOI, and we are here because we're simply on tour for the release of our new album, Pure Scandinavian Darkness. Sweet. Now, we're actually here because we want to talk to you about, it's a delay here. That is annoying. Okay, that's all good. We're actually here because we want to talk about bitflips. And bitflips are caused by, they're caused by, it doesn't change. Engineer? It's like it switches here, and it takes a second or two to change there. That's not going to work.
Are you going to try? No, me neither.
We need to do some adjustments because we can't have lag in presentations.
Take break. Maybe we'll try the...
No, it's not the...
clickers?
It's the HDMI coming out.
Oh, yeah.
I guess we're going to do it the old-fashioned way and just remove some stuff and see if that works. Okay, that's nice. Let's see if... Oh, yeah, now it's better.
We're back?
Yeah. It was that. We have to use that then.
Yeah, sure.
Okay. I'm extremely sorry for any annoyance.
Cool. Anyway, we're here for our to release our new album, Pure Scandinavian Darkness.
Yeah, bitflips. All right, and bitflips can be caused by space weather, it's high voltage, it's heat, it's voltage, and some other stuff, and it tends to make your and our devices go haywire, and fetch resources from places, and even send credentials and post requests and emails to places that they really weren't supposed to. And if we look at this nice email here, everybody likes to get a nice Slack invite, right? That's something you would like to end up, especially if it's not yours. And we look at the domain, it says VisnQ. That's annoyingly close to the company that we work at, right?
Oh, yeah, sure is. However, if we look at that, it's like seems more of a typo than a bitflip, though. Like a Q is basically next to A on the keyboard. So this is just something that, human mistake, human error happens, right?
It happens all the time. And since we're here to talk to you about bitflips, bitflips are like typos, but for computers and not humans. This happens without any kind of user interaction. And what's really cool with bitflips is that it takes just one change of a bit to change everything. Because if you take this domain, for instance, google.com, the first G in Google is built up on all these ones and zeros. And if you change, let's say, this one from a 1 to 0, well, it turns into google.com. You change these two, and it's google.com. Flip that one, and it's woogle.com. Speaking of W, if you flip this one here in the W in WordPress, you will end up with GordPress. And that's actually a domain you can go and buy if you want to.
Yeah, or not, because we did this presentation earlier in August, and pretty fast after our first presentation, this domain was taken. Not by us, by the way.
Somebody else registered it. Pretty sweet. And that technique by registering domains that have bitflips in them is called bit squatting. And that was a term coined by Artem Dinenberg. And he did a great, cool paper talking about this in DNS and super deep diving and all. But I'm just going to Wikipedia this for you so it gets way faster and just read it straight out. Bit squatting is a form of cyber squatting, which relies on bitflip errors that occur during the process of making a DNS request. These bitflips may occur due to the factors such as faulty hardware or cosmic rays, space weather. When such errors occur, the user requesting the domain may be directed to a website registered under the domain name similar to a legitimate domain, except with one bit flipped in the respective binary representations. Cool. I got super nerd by Dylan A-Ray because a couple of years back, he told me that he bought googleapis.com. And that's extremely similar to googleapis.com. And he said, due to cosmic rays and space weather and other shit, he got lots of loot. And when loot, I'm talking about API tokens and JS file requests and a shitload of other cool things. And I'm like, these days, like, ooh, I want to have me some of that. So I asked him, how can you do this? And he said, oh, no, yeah, it's very simple. All you need to do is to buy some bitflip domains. Then you'll catch all the DNS requests, and you will write some simple code, and then eventually store that in a log file. Easy. Right? Super easy. No problem. And I know you're all super, super smart people that understand everything, how DNS and HTTP flows works and everything. But just to make sure everybody's on the table here, I'm just going to break it down so nobody's missing out, because I didn't fully understand this. So let's say we have this authentication flow where a client would start to request a domain. In this case, it would be some fake made-up WordPress domain. And what's going to happen is that the client is going to do an inline and talk to the root DNS server that's going to say that this is the name server that's responsible for this domain. And it's going to give you an IP address. That IP address, the client will then connect to that web server. It's going to send its GET request. It's going to get this response back here. And then eventually, all happy dandy. But what would happen if some kind of bit-flipping magic happened in mid-transit here that made this device instead go from, it will flip in memory, so WordPress will turn into GorePress. What happens then? Well, it's going to do the same dance again, talk to the inline server, but now it's another name server that responds back with another address, of course, and the client is then going to send the next part of the dance to that server, which is great.
Yeah, however, this is true while we were talking about the OG DNS and like a pure text, plain text HTTP connections here. But we're actually living 2024 now, and in this case, this is what would happen instead.
Sad puppy. And this is due to certificates. Jonah knows shitloads of around certificates. But I'm going to break that down as well. If you have a SANS certificate, for instance, if you want to create a certificate and you want to have that and so it's working, you can either go for a SANS certificate, and then you need to define the different kind of endpoints that you want to have in that certificate. And that's going to be all happy, shiny. Or you can go for a wildcard one. And a wildcard is more or less catching everything that's below here. So the www, the blog, the dev API, all those will be valid.
But only for one level, a single level.
Yes, it's only single level, because if we had this original www.GorePress, that would work. But if you have our.devapi.gorepress.com, which is one level down, you need another certificate because it's going to fail.
And the DNS names nowadays,
long. So it's hard to guesstimate what kind of stuff you need. So instead, in this case, you will need to have another wildcard certificate, and that's going to then serve GorePress and the other on Dev API, and it's all good. And we're still back at here. Yeah, it's super easy, but in reality, it's not. Because it's not that easy, and I realized that when I was playing around and trying to figure these out. Because I realized that I needed to set up a bind9 catch-all server where I will respond to these manually getting these certificates in, and I needed to have a NGX with a proxy to do the certbot dance, and then eventually, have some custom Flask code that I also need to update, and I had to do that every 90 days. So I'm like, okay, cool. You probably can automate this. This is probably going to be doable. But at this time, I'm like, I don't really want to do this anymore. So I'm like, next, and moved on to something else. And forgot about the whole project for 2 years. Until I got an email from my VPS provider that says, dear valued customer, your VPS Flippy McFlippy face is running out of disk space. I'm like, what? That project, that VPS that I had. Interesting. I'm going to see what's happening there. So I logged in, and lo and behold, it was out of disk space in one file. One huge file that we had, it was named Catched, and that was full of loot.
And then, meanwhile in Finland. So I'm a person who loves self-hosting. I have been doing self-hosting everything for better part of the last 20 years, and including basically everything, email, all the cloud services, the stuff that you think you need. For this small story here, we're talking about short domains here. The domains that we use in the presentation, they are not the real ones because we didn't get the permission to disclose that stuff, but it is what it is. We're using Lo-Fi. Fi is the Finnish TLD.
And they look cool.
Lo-Fi for the cool graphics. We're able to see cassette graphics and so on, so we chose those. Anyway, going to the story. I registered this short domain, l0.fi. And I did what I always do with the email and stuff like that. I set up a catch-all email for my personal use. And that allows me to do like cool stuff like creating a unique email address for each service that I use and so on. So when eventually the company sells my data and breaks my heart, I'm able to just block them and get rid of their friends, the spam of their friends. So I did this setup, and quite quickly I noticed that, hey, I'm getting a lot of emails that are not for me, but for bank instead. So what happened here is that, yeah, I have the domain l0.fi, but there's a bank who has lo.fi. O and 0, like visually quite close to each other, but also next to each other on the keyboard. So basic typos, basically, but that meant that now I'm everybody in the bank, all the support emails, everything for their customers who mistakenly make these typos. Not good. I don't really want to be in charge of people's bank details and, that stuff. So I do whatever, whoever responsible researcher would do, contact the bank security via email. So this is quite important. Could you please help me to resolve this? I know that there's no real good technical solution for that, but we need to do something. And I got no response.
Obviously.
Obviously. But yeah, can't blame them. Hard problem, not easy to solve. They probably didn't know what to do. Well, I pick up the phone because I want to get rid of this, like, my security is now everybody's security, and I'm in charge of their bank details. Not good. And I call them, could you please hook me up with somebody who could help me? It's kind of urgent. No, could not find anyone. So the time passes, and I'm getting more and more emails. And do you know this bad boy?
Yep.
It's a printer. But it's also a scanner. And it's kind of like within the bank context, it scans stuff like contracts, so on and so on, all the bank details of the customers in the bank. And you can connect this to a network as well. And if you do, you may want to be sure that you're actually configuring that correctly. So now, my email is filling up with the contract details from one of the bank's branch offices that has this misconfigured bad boy. Oh, crap. I really, really, really don't want to deal with this. But still, nothing, no response from the bank. I didn't get to talk to anyone. So time passes, summer comes along, and what do you do during the summer?
You go on vacation.
You go to a hacker camp. So there was this hacker camp called SHA 2017 in Central Europe. Super awesome camp. There's a lot of people from across the globe actually. And yeah, I met some fellow Finns there, some people from the Finnish CERT. They are super awesome, super awesome. basically part of the hacker community in Finland as well. So they understood the issue and, okay, we'll connect you directly to the bank people who can do something about it. And I was like, awesome, but we need to wait until we get back home so I can actually do something about it. I don't have my keys, I cannot access my infrastructure from here. So they delivered, like they always do. We got home and they connected me with somebody from the bank, a lawyer. This is not really a situation where you want to be as a hacker or a security researcher, but to be honest, the discussion was actually pretty civil, and the only thing that we could do there was me giving out the domain and be done with that. So this is where the story should end, right? L0.fi domain that I owned, gone. But the story actually doesn't end here. So I registered a new domain a couple of years in the future called ki.fi.
Because you like short names.
I love short names. You can fit that into payload much easier. So I'm getting these emails for the same bank. What's up? What's up? Well, if you look at the keyboard, it is actually one-off error. Misplaced hands on the keyboard, and yeah, that's just how it goes. So I'm contacting the bank again. Hi, it's me again. Never guess what. And okay, this time around, I'm not going to give the domain away. They acknowledged the issue, and a bit time goes past, and I noticed that the email stopped coming. They did the smartest thing, got rid of email altogether. All the customer communication happens within their web application and, well, obviously mobile application as well. So this is the actual end of this story.
But it's also the beginning of another one, because we met at Disobey this year in January. I mean, we're friends, we're hanging out, it was a good time, and I told Juna about the amount of loot that I collected, and I was a bit annoyed about the tedious process it was to just create this kind of stuff. So I know that he has a good experience when it comes to automating certificate generation. So I asked him, is there anything that we probably could do with this?
Yeah, we looked through the stack, there's multiple things that we could automate or, figure out our way around. But it would be really, really intriguing to scrap the whole stack and write it from the scratch. But we're not exactly young guys anymore, so I wonder if we are. We probably shouldn't, but should we do it?
Hell yeah.
And that's how it went.
So we scrapped it all and started from beginning again and built a custom DNS server, custom HTTP server, custom mail server, certificate management, payload injection capabilities, multi-protocol support, extended config file, JSON format logging files, and an easy setup that takes 5 minutes for you to run. That was shitloads of work. But it ended up creating the tool, certainly. And certainly is an offensive, defensive tool that's primarily made for, I think, long-term engagement, like red team engagements is similar. It's great for that. And what it does is that it just listens and it says yes to everything. It's your friendly butler, and it delivers on-the-fly generated TLS certificates, which is great, which means that it also has the possibility to inject custom payloads for any request that comes in, and it's a great first-class credential logging service.
Storing your credentials for you, transparently.
Yes, we could keep them. And it certainly would do, if you remember this part, when the bitflip happened, like all these, it flips. So GorePlus is running. Now the client, second part of the flow, is going to send the request coming out to the root server. The root server, in this case, is certainly. And since certainly is a DNS server, it's going to respond nicely. And what it's going to do is going to respond back with the IP address of itself, or whatever you define that it's going to be. It's all configurable. We were recommended by previous research to implement DNS poisoning. And DNS poisoning in this case would be if a request comes in, we will respond back with just not one entry, we'll respond with two. One for the flip domain and one for the original one, both pointing to the same IP address. The problem with that is that the internet dies very fast if you do that.
And,
So,
I mean, like, we're not the bad guys, right?
no. So we hard-coded that it's a TTL of 1 second and no poisoning, and then we're logging that into our flow so we can see the request coming in. But hey, this is open source, so go figure. Anyway, the request comes back to the client with the IP address, which means that the client is now going to start the whole TLS dance.
So yeah, this is basically where we enter to the TLS handshake. The client contacts certainly with the TLS handshake client hello. That tells the domain that they're trying to get the certificate for. And certainly will tell the client to hold up. So while so basically it's not answering anything. So while the client is patiently waiting, certainly will behind the scenes run to the CA and say, like, hey, I need this certificate for this domain that I own. I'm in a bit of a hurry. Could you please? And the CA will ask for this domain ownership verification from Certainly. And Certainly is super happy to provide that because it's also the DNS server and it has ownership of this bitflipped domain. So the certificate authority super happy with the proof of ownership and signs the certificate, sends it to Certainly's way, and Certainly thanks kindly and returns this certificate for the client, releasing the TLS handshake flow.
So now it goes back to the client. This is where the HTTP kind of requests come in. We have now assigned a session that's all good. So the client says, you're going to be super happy, like, oh yeah, that is actually the domain that I was looking for. Sweet, here's the loot. And that's all good. And we'll just take that stuff and store it in a log file because, hey, who knows? Maybe we can use that later. And then do a nice 307 to the client, says, oh, I'm sorry, our mistake. This is actually the server that you're looking for.
This is the way.
So it's moving over to the original web server to continue the flow. Because we realized that if you're really nice to your clients and give them good service, they tend to be returning customers and coming back again for some other kind of shenanigans.
Or not. We can also inject that data. So remember that we're controlling the whole back and forth communication flow here. So when the client contacts Certainly, yet again, Certainly is going to tell them, yeah, you remember, just like the last time, could you hold for a bit? I'm going to dig, I'm kind of old and slow. So while the client is waiting, the Certainly would connect to the original server, the kind of pre-bitflip thing that the client was trying to connect initially, send the request with all the request headers intact. So this allows transparent injections to authenticated requests as well. The web server, original web server, then obviously responds with whatever the original client was expecting. And at this point, we need to make a decision again. So should we just do provide that to the client or not? Or
we could.
We could. Or we could insert something spicy in the response instead. Now inserting something extra spice there, we can return this enhanced response to our original client here. Fuego!
That's perfect. And that is fully customizable. So any kind of shit you can think that come in line, you can inject stuff there. Nice. Now I hear you thinking like, okay, but what kind of domain should we get? How do I get started with this? Cool tool and all, but Luke Young did a great talk when it comes to identifying which DNS, how to get access to like a lot of domains, because that's a bit costly process. And in that, he released a tool called BF Lookup. It's a small Go thing that you run, and what it does is that you take an input, and it's going to do a lookup for that, see if it's available or not, and it's going to do these multiple versions. And if it's a star, that means that it's available for you to register, which is great. All the other ones are being taken, and as you can see in WordPress case here, there's a bunch of them that doesn't seem to belong to them. Interesting. But there were 28 at this stage, this time when we did this, that were up for grabs. And buying 28 domains isn't always that expensive, but the renewal cost is going to ruin you. So it's like we need to funnel down here. We need to identify which one should we really buy. We can't buy all of them, right? So I dug into the research here that was really, really cool, that explained like the difference between the highest chance of 1 turning into 0 or 0 turning into 1. So we would understand which characters that were more important than others. It's a great research paper, way above my pay grade. So I used to enter the final data and said, like, okay, what's the highest probability? And it seems like going from 1 to a 0 is more likely. And it has to do with something, keeping a charge, or it requires more energy to keep a 1 than letting it go.
Electricity and magic, you know, as hackers.
Yeah, perfect. So in this case, I would focus on the characters that had the most 1s, because they were more probable to flip. And the ones that were most interesting to me were these one, O and W, because all these have something called character siblings. They have the possibility to turn into all these different other characters based upon that's the binary build-up. So, and that goes all over the field. It's like O and W are the ones that have the most, from 1 to 0, then C, F, and all these other things, and all the characters.
You fellas there in the back, are you able to see the last line? Perfect. If you would not be, I would have some news for you. But, okay, please.
With some problems. Anyway, so the ones, we can go and we can do it the other way around too. Like, which ones are the one that has most zeros that turns into 1, and that's A and B. And A and B in this case, if you flip this, let's say this, the third bit here, it's called something else, blah, blah, blah. If you turn that 1 to 0, it's going to change if it's a lower or higher character. That's always the way it works. And DNS doesn't care about that at all.
Yeah.
So that's not a problem for us. So we try to identify which are important ones. That's not of importance. If we flip this one, all these 1s to 0, what's going to happen? Yeah, they'll turn into something else. And as you can see here, B in this case has a big probability of turning into a backtick.
I mean, like, we love backticks, but it's kind of useless here in this, like, a DNS concept, though, so probably not.
No, it doesn't work in DNS. It's not high probability ones. And all these different characters have a possibility to turn into something that's not on the DNS RFC standard. We're not interested in those. We want requests coming in. So just remember this. You had all these. This is like the full build-up of WordPress at the beginning of it, right? All it takes is one single 1 to flip, and it turns into something else. It's big chances things are happening. So if we take the O's and 1s, you probably want to know which one of these KG, M, and L are the ones that are most likely to flip into something else. Well, O most likely likes to turn into K. Then it's followed by G and M and so on. It's a very, very interesting way for us just to funnel down. We know which characters that we should focus on. So when we want to buy the domains, obviously in this case the K was taken. But there were 5 other ones that would be interesting for us to buy instead of all the 28. Because they have a higher probability of flipping.
But I wonder, if we could have a bigger impact, like this is bad enough, but can we go, you know, like deeper? Maybe, can we flip TLDs?
Well, thank you for asking. So start with TLDs. What we can do is that we can just curl the latest kind of data of IANA to get all the TLDs. That's like .com and similar stuff, and see how many there are. And there are apparently 1,447 in other lines, so it's 1,446 currently. So I had all these domains, a bunch of domains. I didn't want to do this manually, so I did the thing that any kind of smart person would do. I'll just ask ChatGPT to take all these domains and do a Python script for me and do the comparison to see if any of these domains, like for instance, turns into something that's very similar, because it's way better to flip on the top domain than just, because then you get everything below. And it turns out that there's a bunch of them. There are actually 348 that seems to turn into something else.
That's actually quite a few. And by the way, .ar, the TLD for Argentina, is on that list a couple of times. So there.
Maybe you should look into that.
Yeah, maybe.
Because if you take a domain like .io, which is very, Web3 people, they like that. That flips into .im, and .im is the Isle of Man. This means that you can buy something that's similar to a .io by just spending 20 euros. So somebody already thought that buying metamask.im was a good idea. Good riddance on them. I got a bunch of these .io domains. They bring loot, because you get everything. Sweet. Anyway, but .com is the one that we all would like to have, right? You remember O, we're high probability to flip into something else. Well, it seems like C flips into B, which is great. And .bom, it's a new upcoming GTLD for Portuguese kind of thing, and it means good in some way. And I'm like, oh, that's sweet. So why not pre-register for Amazon.bom?
Look at me, I'm the Amazon now.
Who knows? There's a low probability that they're going to say, maybe we should give that domain to STÖK.
STÖK sounds legit.
But I'm in the list, so I'm happy to have that. Another one that we most likely would love to have, right? That would be .ckm, right? That's not a valid domain that exists today.
Doesn't exist yet.
But we have something called vanity or vanity domains, like Nike, right? That had .nike. That's one of their domains. There's a shitload of other ones. And if you have the if you have the cash to burn, you can do the evaluation fee of $185,000 and see if you can get it.
I mean, yeah, it's not really you buying a TLD for 185K USD. But it's actually, this is just for submitting the request for evaluation. So if you're going to do that, make sure that you have a really good justification why they should create that CLD for you.
There's a quite steep administrative cost. And they only do this every 7 years or so. So if you want to do this, cough up the money now and register an organization that it has KG blah, blah, blah in it, and you're going to be golden. Anyway, the whole idea why we started this whole shenanigans was because I wanted to really understand space shit. I thought that was the reason. So now when we had certainly, we wanted to do a little bit of, at least some kind of real research and do some scientific result thingies because, hey, science, right? So we went out and did some bit squatting and bought about 25 domains from some very high traffic Saas cloud providers and package repos and other things that most of us in here use on a daily basis. Thank you. And let that server run for about 4 months and 20 days, just waiting and hoping for something to happen. And boy, did we get lucky.
We sure did.
Because in May 10th this year, the Earth got hit by the most amazing solar storm that we had in over 20 years. And at this stage, we got certainly up and running, right?
Yeah, we had it running for had it running for a couple of months already, collecting data on high speed. We were seeing a lot of data coming in, and you're like, okay, this solar storm, like, how much data are we gonna get? Like, it's
that's us. We're like super excited, like, whoa, it's gonna be amazing. And then the day came when we decided we didn't touch it at all during the weekend, not at all. And we're like, okay, we committed. So okay, Jonas out traveling. I'm not touching the logs. It's going to be the best freaking thing ever.
And we opened the logs.
But it was nothing.
Nothing. Actually, it's lower than average.
What the?
So we obviously went back, looked at the kind of space weather from the previous periods as well, and tried to do correlation. Did we see anything?
No.
Nothing. So, okay, so we did this presentation first time on August, and just a week and a half before our first presentation, a new research paper was released.
Ta-da.
Looking into correlations with DRAM errors and the cosmic rays. It is a research by Barcelona Supercomputing Center, a huge, huge data set with European Space Agency and University of Athens. And I actually read this paper, found it and read it at London airport on my way to Vegas to present this. So I was like, whoa, like, look at this they actually came to the same conclusion that we did.
Because we didn't really understand. We're like, what are we missing here?
Previous 15 years of research pointed out that the bitflips are mainly happening because of the cosmic rays. This research, we did not find any correlation between those. And actually, they even recommend the previous researchers to go back and revisit their research in the light of their data in order to figure that out.
So we can't blame it on space weather. You can't say that bitflips happen due to cosmic rays. Or you can, but it's not right.
At least the majority of the
yeah. Because the fact remains, during this period, and this is pretty freaking darn cool, we received about 62 million incoming DNS requests on these 25 domains that we had. That turned into about 2.8 million signed TLS requests coming in to our box. And we got about 15,000 emails.
That's a lot of Viagra. And I wonder if you remember this bad boy. They are back.
Yep.
So there's this like a tag scanning thing, and we got some emails as well. Took a look at, well, it seems like we got something non-Viagra. Oh, it's personal details. Let's
throw that away.
I didn't see that. Delete.
And it seems like actually emails have a really, really high probability to just end up here. We have no real idea why, but you will get a lot of juicy stuff coming that way. Meeting invites, all this nice stuff that you probably want to have if you're doing a red team engagement. It's dumpster diving without having to dumpster dive. Anyway, but the most juicy part here is that we actually got about 2,300 unique OAuth and OAuth tokens for multiple Fortune 500 companies. That's a lot of account takeovers. So, and knowing that, we also realized that this is a perfect tool to identify word lists, because with a configuration like you have a split horizon setup, right?
Horizon DNS configuration. So we are basically able to see what is typically you're unable to see from the external network, but only from the inside of the network.
Because somehow they just send that out. And that's perfect for creating custom word lists if you want to fuss or use identify or brute force and shit. It's perfect. Lovely. And we also realized that every time we requested a new certificate, in the beginning we did single certificate for every one of them instead of wildcards. We didn't survive that because we got lost by the scanner boys coming running. And it's like, ooh, new site. I mean, it's going to send everything there. And this is also a great tool to identify what kind of new payloads are people running, because you get all the juicy scanner boy stuff coming in your way. Perfect.
Yeah, so now we're seeing all of these like different things. So you may be thinking like us, what should I do? Like just sit idly and wait for the world to burn around you, or what? Well, like many other things, unfortunately, it begins with taking responsibility of things that are in your control.
Primary people that actually have applications.
Yes.
Customers.
Exactly.
Not us as hackers. We're not responsible.
So the first thing, obvious thing, obviously, registering those domains that are, like one bit away from your OG one. For example, if we look at the WordPress example here, all these are registered basically by different parties, at least judging by the name server records visible here. So don't be like WordPress, but more like Amazon instead. So they did an awesome job here. They basically got everything.
They got all of them.
So yeah, this is a decent start, but the other stuff that you can do is cert pinning. So obviously this is only available for mobile applications and stuff like that, but we actually see a lot of huge percentage of the requests coming our way being mobile devices. However, when doing this implementation, be really careful about it, because we have seen a lot of wrongly created cert pinning things that don't really protect against bit flipping, because they are failing open. They don't know about the domain previously and yada, yada, yada. So take care. We know that security is actually hard. So yeah, tread lightly. My favorite one, though,
and the hardest part.
And the hardest part is going to the core network libraries of programming languages. So OpenBSD has this awesome pledge system, and if we apply the same kind of design philosophy to kind of this sort of protection, we would actually be good. So what it means that during the initialization of the application, we tell the network stack that these are the only domains that we're going to be communicating with. And then we add just a simple step in the TLS certificate validation phase, and to check against the hash, for example, if this is for sure the target domain that we pledged to be talking to only. And if we won't, the connection would just be killed and getting rid of the problem, basically.
Or we can keep on blaming it on DNS, which seems like most companies do. And we can also just keep on living in bliss and ignoring it at all. I'm not judging you in any way or form, but that is not really the ideal case here, because this is happening on a scale where it's way more than we thought it was. So, why is this happening then? Well, the full, real, transparent answer to this is that we have no idea. We have no idea. Why is it happening? This shouldn't be happening. So this is a call for research. We want you to look into this and help us figure out, because the whole argument that this rarely happens is actually faulty. And I think the reason why it seems like the whole community has agreed that this rarely happens because they were rarely got caught. Now, certainly, we catch each and single one. The first flip that ever happens, whatever kind of request, we collect it, because we now can listen and generate certificates for it. And we've seen an exponentially higher number of visits and token releases from apps and devices. People create apps, they run on the devices, and it happens to just hit the service. There's not a specific kind of device that stays out. It's not Android versus iPhone or something, but there are some TVs that seem to be really crappy. They seem to throw iCloud tokens around. Tokens around. Could it have something to do with Rowhammer, maybe? I think that's what we thought, that it was an excessive reading. The app is running in the phone, and maybe over and over and over again, and it flips in memory. That could be a part, but it could also be CPU or CPU cache or memory cache channels and networking libraries.
Snipe, if you're anything like us, you probably got your brain racing right now thinking of different applications for this stuff. And yeah, we highly, highly recommend you to dig into that. And because of that, certainly the tool that we developed for this research, it's released as an open source project, so feel free to go and grab it. It's available at github.com/happycakefriends, because we're not the bad guys, right? / certainly. Yeah.
Please join us and dig into this. It's open, it's MIT, so you can just start to play around with it. And we're not going to take any questions now, but we do have stickers. So we'll meet you guys outside. And this is JOOHOI. I'm STÖK at STÖK on all socials, and thank you for coming to our talk.
Thank you.